So in this video I will explain how to find the complementary function of a differential equation. For that I will explain using a second order differential equation. Consider a second order differential equation: d square y by dx square plus a1 into dy by dx plus a2y is equals to phi of x. Right hand side, if phi of x is equals to 0, then we call it as a homogeneous differential equation. If it is not equal to 0, then we call it as a non-homogeneous differential equation. Now what is the procedure to solve? So we are going to substitute d square y by dx square is equals to capital D square y, and dy by dx is equals to dy, so that the given equation becomes d square y plus a1 dy plus a2y is equals to phi of x. Take a y common in the left hand side, so it becomes d square plus a1d plus a2y is equals to phi of x. Put d is equals to m, we get the auxiliary equation, that is m square plus a1 into m plus a2 is equals to 0. So we will not write down y in this on this. So by solving the auxiliary equation, we will get the complementary function, and by solving the by using the right hand side, we will obtain the particular integral. So what are the different types of the complementary function? So type 1. So if the roots of the auxiliary equations are real and distinct, then that is, we will take m1 and m2 as the are the two roots, such that m1 is not equal to m2. Then we will write the complementary function as c1 e power m1x plus c2 e to the power of m2x. So for example, if 2 and 3 are the roots, then the complementary function will be c1 e to the power of 2x plus c2 e to the power of 3x. For example, if minus 1 and minus 2 are roots, then complementary function will be c1 e power minus 1x plus c2 e power minus 2x. Similarly, if 2, 3 and 4, if suppose we have three roots for a cubic equation, third order differential equation, then complementary function will be c1 e power 2x plus c2 e power 3x plus c3 e power 4x, because all three are real numbers and they are not equal. The second type will be, so roots are real and equal. Suppose that both the roots are same, like m1 is equals to m2, then we'll write complementary function as c1 plus c2x into e power mx. For example, 1 comma 1 are the roots, then complementary function will be c1 plus c2x into e power 1x. If minus 2 and minus 2 are roots, same root is repeated twice, then complementary function will be c1 plus c2x into e power minus 2x. If the root is repeated thrice, minus 1, minus 1, minus 1 are the roots of the auxiliary equation, then complementary function will be c1 plus c2x plus c3x square into e power minus 1x. You note the difference between when the roots are repeated twice, we will write c1 plus c2x. If it is repeated thrice, we will write the complementary function as c1 plus c2x plus c3x square. So third type will be if the roots are complex, then that is m is equals to a plus r minus ib. A is called the real part of the complex number and b is called the imaginary part. So then the complementary function will be e to the power of ax plus c1 cos bx plus c2 sin bx. For example, m is equals to 2 plus r minus 3i. 2 is the real part and 3 is the imaginary part. So real part is this. So we'll write e power 2x. Imaginary, using imaginary part, we'll write c1 cos 3x plus c2 sin 3x. For example, another example, if the roots are minus 1 plus or minus root 2 I, minus 1 is real part and root 2 is imaginary part. See, e to the power of minus 1x plus c1 cos root x plus c2 sin root x. The fourth type will be if the roots are imaginary. If there is no real part, then complementary function will be c1 cos bx plus c2 sin bx. So for example, if plus or minus 2i are the roots, that is 2 is called b. So we'll write the complementary function as c1 cos 2x plus c2 sin 2x. And if plus or minus 3i are the roots, then it will be c1 cos 3x plus c2 sin 3x. So I'll take up this using an example. Solve this differential equation. So which means we'll substitute this by capital D square y dy by dx by capital Dy, so that the equation becomes d square y 5 dy plus 6y is equals to 0. So you take y common, so that it becomes d square plus 5d plus 6 into y is equals to 0. Put d is equals to m. So the auxiliary equation m square plus 5m plus 6 is equals to 0. So if you can use the calculator to find the roots of this equation. The roots are minus 2 and minus 3. So both are real numbers, and they are not equal. So what is the nature? Real and distinct. So we will write the complementary function as c1 plus c1 into e power minus 2x plus c2 e to the power of minus 3x. So I'll take up a third order differential equation, d cube y by dx cube plus 6 d square y by dx square plus 11 dy by dx plus 6y is equals to 0. D cube means I'll write capital D cube. 6 into this will be capital D square. 11d plus 6 into y. So put d is equals to m. So auxiliary equation will be m cube plus 6m square plus 11m plus 6 is equals to 0. So therefore the roots are minus 1, minus 2, minus 3. All the three roots are real numbers and they are not equal. So their nature will be real and distinct. So therefore complementary function will be c1 e to the power of minus 1x plus c2 e to the power of minus 2x plus c3 e to the power of minus 3x. I'll take up another example. D square y by dx square minus 4 dy by dx plus 4y is equals to 0. So this d square means it will be capital D square. This will be 4d plus 4 into y. The put d is equals to m, so that it will be m square minus 4m plus 4 is equals to 0. The roots are 2 comma 2. When you solve this equation by using the calculator, you will get only one root in the calculator, which means the root is repeated twice, because same root, it's a quadratic equation, it is repeated twice. Therefore complementary function is c1 plus c2x into e to